Simple matching coefficient. Difference with the Jacquard index. The SMC is very similar to the more popular Jacquard index. The main difference is that the SMC has the term M0 \displaystyle M0 in its numerator and denominator, whereas the Jacquard index does not. Thus, the SMC counts both mutual presences when an attribute is present in both sets and mutual absence when an attribute is absent in both sets as matches, and compares it to the total number of attributes in the universe, whereas the Jacquard index only counts mutual presence as matches, and compares it to the number of attributes that have been chosen by at least one of the two sets. In market basket analysis, for example, the basket of two consumers who we wish to compare might only contain a small fraction of all the available products in the store, so the SMC will usually return very high values of similarities even when the baskets bear very little resemblance, thus making the Jacquard index a more appropriate measure of similarity in that context. For example, consider a supermarket with 1,000 products and two customers. The basket of the first customer contains salt and pepper, and the basket of the second contains salt and sugar. In this scenario, the similarity between the two baskets as measured by the Jacquard index would be 1/3, but the similarity becomes 0.998 using the SMC. In other contexts, where 0 and 1 carry equivalent information symmetry, the SMC is a better measure of similarity. For example, vectors of demographic variables stored in dummy variables, such as binary gender, would be better compared with the SMC than with the Jacquard index, since the impact of gender on similarity should be equal, independently of whether male is defined as a 0 and female as a 1 or the other way around. However, when we have symmetric dummy variables, one could replicate the behavior of the SMC by splitting the dummies into two binary attributes, in this case, male and female, thus transforming them into asymmetric attributes, allowing the use of the Jacquard index without introducing any bias. By using this trick, the Jacquard index can be considered as making the SMC a fully redundant metric. The SMC remains, however, more computationally efficient in the case of symmetric dummy variables, since it does not require adding extra dimensions. The Jacquard index is also more general than the SMC and can be used to compare other data types than just vectors of binary attributes, such as probability measures.